November 1944, Peleliu Island. Corporal James Donovan is pinned inside a coral cave, staring at Japanese bunkers that have survived 58 straight days of naval and artillery fire. In his hands is a Thompson submachine gun, deadly against men, but worthless against concrete. 14 Marines are already dead trying to break them. Then his sergeant slides a wooden crate across the rock. Red lettering, experimental. Inside are rounds unlike anything Donovan has seen. The Japanese have a name for them: Bakudan Akuma. Each cartridge carries 48 grains of C2 plastic explosive, transforming a Thompson into something it was never meant to be, a Han bunker killer. Donovan aims at a firing port 47 yards away and squeezes the trigger. The impact flashes white. Concrete fractures outward in a starburst. What cost 14 lives in 4 days is finished in 48 minutes, with only one Marine wounded. Between late 1944 and 1945, 14.2 million of these rounds are secretly produced and rushed to Peleliu, Iwo Jima, and Okinawa. Units that carried them suffer 31% fewer casualties in bunker assaults. Then the weapon disappears. Just die. Hidden, forgotten for 31 years. This is the story of the Boom Devil, the submachine gun round that turned Japanese fortresses into coffins. November 1944, Peleliu Island. By the 58th day of fighting, the island no longer looked like land. It looked like something broken and burned down to its bones. Coral ridges had been blasted into jagged teeth. Palm trees stood stripped and blackened. The ground itself seemed hostile, sharp enough to cut boots and hands alike. For the men of the US Marine Corps, Peleliu had become a lesson learned the hard way. Corporal James Donovan was 22 years old, crouched inside a coral cave barely tall enough to kneel in. The space smelled of cordite, damp stone, and decay. His shoulders were pressed tight against the rock as he leaned forward, peering through a narrow gap toward the ridgeline ahead. 30 feet away, Japanese bunkers sat exactly where they had been for nearly 2 months. They had survived battleship guns. They had survived artillery barrages. They had survived bombing runs that were supposed to erase everything on the surface of the island. Those bunkers were still firing. In Donovan's hands was a Thompson submachine gun. It was a weapon designed to dominate close-range combat, built to overwhelm enemy infantry with heavy .45 caliber fire. Against men in the open, it was terrifying. Against what lay ahead, it was useless. Every Marine on Peleliu knew this by now. For 4 straight days, Donovan's platoon had tried to crack the same fortified positions. They crawled forward under interlocking machine gun fire. They brought up flamethrowers only to see operators cut down before they could close the distance. Bazooka teams fired at concrete faces, watching rockets glance off at bad angles or detonate harmlessly on reinforced surfaces. 14 Marines had already been killed attempting to reach those bunkers, not because they lacked courage, but because nothing they carried could reliably destroy concrete that thick. The Japanese defenders had months to prepare. They carved caves into coral limestone, reinforced them with steel logs and aggregate concrete, and connected everything with tunnels invisible from above. Naval guns shattered the surface. Each failed assault taught the same brutal lesson. The closer you got, the more likely you were to die. Donovan knew the firing ports by heart now. Rectangular openings cut into gray concrete, positioned just high enough to rake the approaches with machine gun fire. He had seen men fall trying to rush them. He had seen others pinned down for hours, unable to advance or retreat. The Thompson in his hands felt heavy, familiar, and completely inadequate. Then his sergeant appeared beside him, crawling low across the coral. He did not shout, he did not explain. He simply shoved a small wooden crate forward until it rested between them. The crate was marked in red experimental. That word carried weight in a place where most things were already deadly. The sergeant pried the lid open just enough for Donovan to see inside. The cartridges were wrong, too long, too heavy. The projectiles were copper-colored and blunt in a way that made them look unfinished or unsafe. "Load these," the sergeant said quietly. Donovan hesitated only long enough to register the unease in his stomach. He reached into the crate and lifted one round. It felt dense, heavier than a standard .45. This was not ordinary ammunition. Intel had picked up a name in intercepted radio traffic, the sergeant added. A name the Japanese were already using, Bakudan Akuma, Boom Devil. No one explained why it worked. No one offered guarantees. There was only an instruction and a deadline. In a few minutes, the naval barrage would lift. When it did, the Marines would have to move again, whether they were ready or not. Donovan loaded the magazine carefully. Each cartridge slid into place with a dull, unfamiliar sound. He seated the magazine, worked the action, and felt the bolt close with a resistance that wasn't there before. The firing port he'd been assigned lay 47 yards away. He centered the front sight on the concrete opening and waited. When the order came, Donovan rose from cover and squeezed the trigger. The shot did not sound like a grenade. There was no rolling thunder. Instead, there was a sharp crack and a flash of white light at the point of impact. The concrete around the firing port fractured outward in a sudden, violent pattern. Donovan fired again and again. By the seventh shot, the bunker that had resisted 4 days of assault was coming apart from the inside. What had cost 14 lives in 4 days would be finished in 48 minutes. At that moment, Donovan did not know he was firing ammunition that would be produced by the millions, rushed to islands across the Pacific and quietly removed from history for more than 3 decades. He only knew that the bunker in front of him was finally breaking, and that everything about this battle was about to change. The collapse of that first firing port did not happen by accident. It happened because the problem the Marines faced on Peleliu was never about bravery or firepower. It was about design. The American infantry arsenal had been built for a different kind of war. By late 1944, US forces possessed overwhelming naval and air superiority. Battleships carried guns that fired shells weighing more than a ton. Aircraft dropped bombs that could flatten entire city blocks. On paper, no island garrison should have survived what Peleliu absorbed. But paper did not account for coral caves and time. They were fighting from a 3-dimensional fortress carved into the island itself. Over months, engineers and labor units transformed natural cave systems into layered defensive networks. Firing ports were angled, chambers were reinforced, tunnels connected positions that could not be seen or targeted from above. Every bunker was designed with one assumption in mind, that the enemy would rely on blast and penetration from the outside. Naval guns shattered surface features and collapsed entrances, but the defenders simply withdrew deeper. Bombs sealed cave mouths, only to be bypassed through secondary exits. Even direct hits often failed to reach the men inside. By November 1944, intelligence officers were forced to admit an uncomfortable truth. Many Japanese defenders on Peleliu were alive inside positions that had endured days of bombardment heavier than anything used during the entire Guadalcanal campaign. For the Marines, the consequences were immediate and lethal. The M1 Garand, the backbone of American infantry, fired a powerful .30 caliber round capable of penetrating wood, earth, and lightly reinforced cover. Against solid concrete, its effectiveness dropped sharply. At best, it chipped. At worst, it flattened against the surface. The M1 carbine, lighter and faster handling. And the Thompson submachine gun, labeled for its stopping power in close quarters, was never designed to defeat fortifications. Its .45 ACP ammunition carried enough energy to incapacitate a man instantly, but not enough velocity or structural integrity to punch through reinforced concrete. A Thompson round striking a bunker face often shattered on impact after penetrating barely a couple of inches. The result was predictable. To kill the defenders, Marines had to get closer. Flamethrowers offered one solution. Fire could reach into openings and tunnels where bullets could not. But flamethrower operators had to approach within dangerously short distances, often under direct machine gun fire. They carried tanks of fuel that made them immediate targets. Casualty rates among flamethrower teams were brutal. Combat engineers provided another option. Satchel charges and demolition packs could blast them. Those men advanced slowly, exposed, and often did not survive long enough to withdraw. On Peleliu, engineers suffered casualty rates that exceeded 40%. Every successful bunker reduction came at a horrific cost. Every failure stalled the advance and forced the Marines to repeat the same lethal approach again. They did not rush counterattacks or mass formations. Instead, they waited. They allowed American fire power to expend itself against concrete and stone. Then, when Marines advanced to close range, they opened fire from protected positions with clear fields of view. It was a system designed to trade territory for lives. By early October 1944, the 1st Marine Division had suffered thousands of casualties on an island barely 2 miles long. The numbers were staggering. Entire units were depleted while the enemy remained entrenched. Commanders began to recognize that the problem was not the courage of their men or the scale of their firing. It was the absence of a weapon that could deliver explosive force into a bunker from a position of relative safety. There was no portable infantry weapon capable of doing that. Artillery was too blunt and imprecise at close range. Air support could not reliably target firing ports hidden beneath ridgelands. Rifles and machine guns could suppress. The Marine Corps needed something that did not exist behind the scenes. The Ordnance Department had already reached the same conclusion. Reports from Tarawa in November 1943 had crossed desks in Washington and Honolulu with alarming speed. Casualty figures spoke louder than doctrine. The traditional approach to bunker warfare was unsustainable, against a defender willing to absorb punishment underground. Engineers were given a simple directive through small openings without sending men to their deaths. The solution they pursued violated nearly every principle of conventional small arms. Explosives did not belong in submachine gun ammunition. The risks were obvious: premature detonation, weapon failure, catastrophic accidents. For decades, explosive small-caliber projectiles had been considered impractical, unreliable, or outright dangerous. But desperation rewrote the rules. Instead of asking how to build a bigger gun, engineers asked a different question. What if the explosive charge did not need to penetrate deeply? What if it only needed to arrive intact at the surface and detonate there? The bunker itself would become the weapon. Concrete, when shattered violently, produced lethal fragments. In confined spaces, those fragments ricocheted with tremendous energy. A small explosion in the wrong place could turn a firing port into a funnel of destruction directed inward. It was a subtle shift in thinking, and a radical one. Rather than defeating the bunker's strength, the idea was to exploit it. The concept was developed in near total secrecy. Security classifications were so strict that even division-level intelligence officers in the field were unaware such ammunition existed. The project, by urgency and shielded from scrutiny, by the time the first crates reached Peleliu in November 1944, the weapon had already been tested, approved, and rushed into combat under extraordinary restrictions. The Marines who received it were not given lectures or technical manuals. They were given rules. Fire only in semi-automatic. Do not overheat the weapon. Do not discuss the ammunition outside your unit. And above all, do not miss for the men facing concrete bunkers that refused to die. That was enough. They did not need to understand the chemistry, the metallurgy, or the engineering compromises hidden inside each cartridge. They only needed something that worked. What happened at that firing port on Peleliu was the first proof that it did, and once that proof existed, it could not be contained. The decision to place explosives inside a submachine gun round was not a breakthrough born from confidence. It was born from failure. By early 1944, American ordnance engineers were facing reports that could no longer be ignored. Again and again, battlefield summaries described the same outcome. Casualty numbers from Tarawa, Saipan, and smaller engagements made it clear that existing infantry weapons were fundamentally mismatched to the environment of Pacific Island warfare. The problem was not penetration alone, it was access. Bunkers did not need to be destroyed completely to be neutralized. Smoke, fragments, overpressure, and these were the real killers in confined spaces. Yet the weapons available to infantry required Marines to get dangerously close before any of those effects could be delivered. Ordnance officers began exploring ideas that had previously been dismissed as unsafe or impractical. One proposal, initially shelved years earlier, resurfaced under a new lens. explosive projectiles for small arms. The concept was controversial from the start. Explosives and automatic weapons did not mix, the risk of accidental detonation, weapon failure, or catastrophic incineration did not matter, was obvious, fragments in explosive boil. But desperation alters standards. Instead of designing a projectile to penetrate deeply before exploding, engineers focused on a different requirement. The round only needed to reach the surface of a bunker intact. Detonation would occur on impact. Using the bunker's own concave, the bunker would destroy itself. This shift in thinking drove the design of what would become the M1 frangible grenade cartridge. Development was assigned to Frankfurt Arsenal in Philadelphia, a facility with the metallurgical expertise and production flexibility. Reconfirmantalized immediately, security classifications restricted information to a narrow circle of engineers, chemists, and ordnance officers. Even within the arsenal, few understood the full purpose of what they were building. The cartridge outwardly resembled an oversized .45 ACP round, but internally it was entirely different. Instead of assigned a frangible copper-based matrix loaded with dense particulates, it needed to survive acceleration through the barrel, yet shatter reliably on impact. The solution was a compressed copper alloy embedded with tungsten particles. The tungsten increased mass and created internal stress points that ensured fragmentation at the moment of impact. The projectile enough to break apart instantly against hard surfaces. Inside that frangible shell sat the real innovation. A small charge of composition C2 plastic explosive. C2 was chosen not for maximum power, but for stability. The charge weighed just 48 grams, a fraction of what a grenade carried. Yet in confined spaces it would be devastating. The explosive was molded to fill the core evenly, avoiding voids that could cause inconsistent detonation. The most delicate component was the detonator. Standard impact fuses were far too large for a .45 caliber projectile. Engineers instead turned to piezoelectric technology, using crystals that generated an electroration. Miniaturizing such a system was a manufacturing challenge, unlike anything attempted for small arms ammunition. The resulting detonator was no larger than a grain of rice. When the projectile struck a hard surface, the rapid deceleration compressed the piezoelectric element. Ignited a tiny primary explosive, which in turn initiated the C2 main charge. Millisecond after impact. Detonation had to occur after impact, but before the projectile disintegrated completely. Extensive testing refined this balance, producing a detonation delay measured in hundredths of a second. The cartridge case explosive payload and detonator. Engineers extended the case length beyond standard .45 ACP dimensions. Chamber pressure had to be carefully limited to prevent excessive heat buildup or structural stress on weapons never designed to fire explosive rounds. The Thompson submachine gun was chosen not because it was ideal, but because it was forgiving. Its heavy barrel, robust construction, and moderate rate of fire allowed it to handle the unusual ammunition without immediate modification. Engineers reduced propellant pressure, deliberately trading velocity for safety. The result was a projectile that traveled slightly slower than standard .45 ACP, but carried comparable kinetic energy, with the added destructive effect of an explosive payload. Testing took place under strict controls. At Aberdeen Proving Ground, engineers fired the XP. Conventional Thompson ammunition produced shallow craters. The frangible grenade cartridge punched through the surface, detonated against the interior face, and sent concrete fragments flying backward with lethal velocity. The effect was unmistakable. Fragments penetrated wooden boards placed behind the target, over pressure. The combination of blast and spalling proved far more effective than penetration alone. The ammunition was not without flaws. At oblique angles, detonation could be inconsistent. Excessive barrel heat, ingrate components. Engineer addressed these limitations through Doctrine. cooling periods would be enforced, production times were compressed beyond peacetime standards. Normal development cycles measured in years were reduced to months. General officers authorized urgent priority classification. After reviewing Cat 44, the cartridge had moved from concept to field-ready status. Distribution was handled with extreme secrecy. Crates were marked with hazard warnings and special handling. Instructions, storied requirements, specified temperature limits, separation from conventional ammunition, and immediate reporting of defects. Units receiving the ammunition were not briefed on its origins or design. When the first shipments reached Peleliu in November 1944, few Marines understood what they were holding. They only knew it was different, dangerous, and reserved for situations where nothing else worked. Within hours of its first combat use, the results spoke for themselves. What had been theoretical, a submachine gun, had been turned into a weapon capable of breaking fortifications, and once that line had been crossed, the consequences would ripple far beyond Peleliu. The silence after the naval barrage was always the worst part. 14-inch shells from offshore battleships screamed overhead and slammed into the ridgeline with enough force to make the ground jump. Each impact felt final, decisive, as if nothing could survive what was happening above. And then it stopped. The sudden quiet pressed down on the Marines like a physical weight. Everyone knew what came next. The bombardment never destroyed everything. It only marked the moment when men had to stand up and find out who was still alive. Corporal James Donovan felt the pause stretch. His hands were steady now, not because he felt confident, but because there was nothing left to doubt. He had followed the instructions. Whatever happened next was already in motion. The firing port sat exactly where it always had, a dark rectangle cut into concrete, just high enough to command the approach through binoculars earlier that morning. Donovan had seen the barrel of a Japanese machine gun inside it. That gun had killed 5 Marines the day before. The order came down the line. Donovan rose from cover and brought the Thompson up to his shoulder. The distance was measured, not guessed, 47 yards. Close enough to see detail, far enough that a mistake would be fatal. He squeezed the trigger. The Thompson recoiled harder than normal, sharp and abrupt. The sound was wrong, not the familiar flat crack of .45 fire, but something tighter, more brittle. A fraction of a second later, a flash of white light bloomed at the firing port. The explosion was not loud. There was no rolling concussion. Instead, it sounded like something snapping under enormous pressure. The concrete around the opening fractured outward in a sudden star-shaped pattern. Chunks of material the size of baseballs flew backward into the bunker. Dust poured out through the damaged opening. For the first time in days, the firing port was silent. Donovan fired again. The second impact widened the fractures. More concrete collapsed inward, exposing the interior of the position. Through the dust, Donovan saw movement, and figures scrambling away from the opening, not advancing, not firing, but retreating, deeper into the bunker. Someone beside him whispered a curse. Donovan kept firing. Each shot followed the same pattern. The concrete face that had absorbed days of bombardment began to come apart under a weapon never meant to do this kind of work. After the 7th shot, the front wall of the firing port gave way entirely. What had once been a controlled aperture was now a ragged opening large enough to see into the bunker chamber itself. Inside, the Japanese machine gun lay on its side. Its operator was slumped against the wall, unmoving. To Donovan's left and right, other Marines were firing their own experimental rounds. The sound established a rhythm across the ridgeline. Whack, crack, crack. It sounded less like a firefight and more like demolition. Within 90 seconds, Donovan emptied his magazine. 15 rounds fired. Most had struck true. The bunker that had dominated the approach that morning now looked hollowed out, its walls fractured and bleeding dust and smoke. The Japanese fire from that position had stopped completely. As they advanced, Donovan reloaded with conventional ammunition. Saving the explosive rounds for the next hard point, the lesson had already been learned. You did not waste the new ammunition. You used it where it mattered. When they reached the shattered bunker, The cause of death was immediately obvious. They had been killed by the bunker itself. Concrete fragments had torn through the enclosed space at lethal velocity. The explosive force had turned the structure inward, converting protection into shrapnel. In the confined chamber, there had been nowhere to run. The next bunker fell faster, and then the next. Cave entrances. Second, each time a few carefully placed shots were enough to neutralize positions that had resisted days of assault. The effect spread quickly through the unit. Men who had spent days pinned down now moved forward with something dangerously close to confidence, not recklessness, certainty. By the time the action ended, 48 minutes had passed since Donovan fired the first round. 11 bunkers were neutralized. The cost was starkly different from the days before. 1 Marine wounded by return fire, no bodies piled in front of concrete openings, no engineers crawling forward under fire with demolition packs. Radio operators intercepted Japanese transmission describing a new threat, a weapon that shattered bunkers from the outside, a weapon that made concrete dangerous to the men hiding behind it. They called it Bakudan Akuma, Boom Devil, by nightfall. Marines across Peleliu were talking about it in low voices. Not as a rumor, but as something they had seen with their own eyes. A line had been crossed for the first time since the landing. The bunkers were breaking faster than men were dying, and once that balance shifted, the entire battle changed with it. What happened at Donovan's firing port did not stay isolated for long. Combat has a way of spreading information faster than any briefing ever could. Men who had watched concrete shatter under the first explosive Thompson rounds told others. Platoon leaders passed the word. Ammunition crates were redirected. By the end of that day, the new rounds were no longer an experiment confined to a single position. On Peleliu, the change was immediate and measurable. Positions that had stalled entire companies for days were now reduced in minutes. Marines stopped throwing themselves forward in desperate rushes. Instead, they identified firing ports, cave mouths, and reinforced embrasures, and addressed them from a distance that would have been suicidal. The bunker no longer dictated the terms of engagement. The effect was not limited to destruction, it altered behavior. Japanese defenders had built their entire defensive system around the assumption that concrete meant survival. They waited out bombardments, confident that American firepower would exhaust itself on the surface. When Marines advanced, the defenders expected close-range fights, where the bunker's protection mattered most. The Boom Devils shattered that assumption. Radio intercepts began to reflect confusion and alarm. Messages described bunkers collapsing inward, concrete walls producing fragments that killed the men behind them. For the first time in the campaign, defenders abandoned positions, not because they were overrun, but because they were no longer safe inside them. That psychological shift mattered as much as the physical destruction. On Peleliu, units equipped with the explosive ammunition reported dramatically lower cattle steer. They appeared in after-action reports, casualty summaries, and operational analyses. Where bunker attacks had previously cost multiple lives per position, Marines now recorded single-digit minutes and minimal losses. The pattern repeated itself Elinetian mites. The rounds were moved quietly, distributed only to units engaged in intense cave and bunker fighting. Iwo Jima received its share. There the scale of fortifications surpassed anything encountered before. The island was honeycombed with hundreds of interconnect positions carved into volcanic rock. Mount Suribachi alone contained dozens of bunkers and firing ports positioned to cover every approach. Traditional methods struggled again. Marines fired controlled shots into firing ports, collapsing openings and neutralizing defenders without having to storm the entrances. Some positions were bypassed entirely once rendered incapable of effective fire. Others became sealed dooms, entombing defenders who could no longer fight or escape. Instead of advancing in short, bloody bursts, units moved steadily, breaking resistance node by node. At Okinawa, the ammunition reached its widest deployment. The battle would last nearly 3 months and involve hundreds of thousands of troops. Japanese defenses were extensive fire, durade, and deeple entrenched. Here the numbers told the story most clearly. units issued the explosive Thompson ammunition experienced casualty rates significantly lower than those using conventional weapons and tactics alone. Studies conducted after the campaign estimated reductions on the order of 30% during bunker assaults in a battle measured in tens of thousands of casualties. That difference mattered. Production ramped up accordingly. Between late 1944 and the summer of 1945, Frankfurt Arsenal began to prom bridges. The pace strained resources. Each round required careful assembly, inspection, and handling. Detonators were hand-built. Explosive charges were injected under strict controls. Security never relaxed. The ammunition never appeared in standard ordnance manuals. Distribution lists were tightly controlled. Crates were tracked separately from conventional supplies. Storage requirements remained strict and mishandling was treated as a serious offense, despite the numbers. The rounds were sensitive to heat. Sustained automatic fire risked catastrophic failure. Humidity degraded internal components, especially in tropical environments. Some rounds failed to detonate, others detonated premature, under Vincennes and attempted countermeasures. Documents record Morta showed efforts to thicken concrete, angle firing ports, and reinforce vulnerable surfaces. Some bunkers were modified, but adaptation takes time. American forces adapted faster. Marines learned to fire at perpendicular angles. They placed multiple shots close together to weaken structural integrity before collapse. They alternated weapons to manage heat buildup. Doctrine evolved in real time, guided by what worked and what didn't. But it changed the calculus. Bunkers were no longer places of relative safety. They became liabilities. Defenders could not simply wait out bombardment and kill attackers at close range. The Marines had gained a way to reach inside without sacrificing men to do it. This shift affected Japanese decision-making as well. Interrogations and captured communications revealed growing fear of bunker collapse. Some defenders chose to abandon positions earlier. Others surrendered under conditions that would have been unthinkable in earlier campaigns. The weapon's influence extended beyond immediate combat results. For the first time, a submachine gun, a weapon associated with close-range suppression, had demonstrated the ability to defeat hardened fortifications without support from engineers, flamethrowers, or heavy explosives. It was an uncomfortable success. The ammunition was expensive, and the ethical implications of explosive small arms projectiles were already being debated in quiet corners of the military establishment. Yet on the battlefield, those concerns mattered less than outcomes. Men came home alive who would not have survived a week earlier. By mid-1945, the Boom Devil had become an accepted, if rarely discussed, tool of Pacific warfare. Its presence was felt, its name whispered, but its details remained hidden, and then almost as suddenly as it appeared, it stopped. Japan surrendered in August 1945. Production orders were canceled. Remaining stockpiles were sealed and removed from circulation. The ammunition that had altered bunker warfare vanished into storage facilities and classified records. To the men who had used it, the silence that followed was strange. They had seen concrete fail. They had seen battles turn, and then they were told not to speak of it. The weapon that had reduced casualties and broken fortifications did not become part of popular memory. It did not appear in post-war manuals or public histories. For decades, it existed only in the recollections of veterans bound by secrecy and the fading traces of classified documents. What the Boom Devil accomplished. But its story was far from over. The Boom Devil worked, but it was never a perfect weapon. From the moment it entered combat, its limitations were obvious to the men who carried it. The same qualities that made the ammunition devastating also made it dangerous. But not just to the enemy, but to the Marines using it. Each cartridge carried an explosive charge inside a thin metal shell. That alone placed strict limits on how it could be handled, stored, and fired. The Thompson submachine gun had not been designed for this kind of stress, and the margin for error was narrow. Heat was the first problem. Standard .45 speed ammunition allowed sustained fire without concern beyond accuracy. Barrel temperature became a critical factor. Excessive heat increased the risk of premature detonation, especially if a round remained chambered too long. Operators were instructed to fire only in semi-automatic mode and to pause after a limited number of shots. Ignoring those rules could recognize warning signs: the handguard growing uncomfortably hot, smoke rising from the barrel, brass ejecting with discoloration, turning from gold to dull purple-brown under heat stress. When those signs appeared, firing stopped immediately. Some units adapted by carrying two Thompsons, alternating between them to manage temperature. It was an improvised solution, but it worked. Humidity created another problem. Constant moisture seeped into everything. Over time, humidity degraded the piezoelectric components inside the detonators. Failure rates climbed well beyond acceptable levels. Rounds either failed to detonate or detonated inconsistently. A dud round was not just ineffective. The FROMs emerged. Field manuals were updated as problem emerged. Any sign of corrosion, deformation, or discoloration meant the round was discarded. Ammunition handling became a daily ritual, not a background task. Accuracy suffered as well. The Frand assembled under wartime conditions. Minor inconsistencies in construction affected balance. At close range, the effect was negligible. Beyond 75 yards, accuracy dropped enough to make hits unreliable. This limitation shaped Doctrine. The ammunition was reserved for close-range bunker fighting, exactly where the risk was greatest and the reward highest. Weight added another burden: a fully loaded 20-round magazine of explosive ammunition. Marines already carried heavy loads: weapons, ammunition, water, rations, medical gear. The added weight of explosive magazines was not trivial. Combat loads were adjusted accordingly. Most men carried a mix: a limited number of explosive magazines for hard targets, and convention ammunition for everything else. Then there was the issue no training manual could fully address. Even experienced Marines were uneasy handling ammunition that could explode on impact. The idea of firing an explosive from a shoulder-fired weapon went against instinct. Accidents were rare, but the possibility lingered in every shot. The Japanese, meanwhile, attempted to exploit these weaknesses. Firing ports were angled to deflect incoming rounds. Concrete thickness was increased at known weak points. Some positions added internal blast baffles to absorb fragmentation. None of these measures solved the problem entirely. American units adapted faster than the defenses could evolve. Marines learned to fire at perpendicular angles, to cluster shots close together, to target structural joints rather than flat surfaces. What began as an experiment turned into a practical body of field knowledge passed quietly between units. Still, the ammunition was never universally trusted. Commanders understood that the Boom Devil was a specialized tool, not a replacement for all infantry weapons. Its effectiveness came with cost, complexity, and risk. It demanded discipline from the men who used it, and careful concerns surfaced as well. Explosive small arms ammunition occupied a gray area in the laws of war, while no existing treaties explicitly prohibited its use. Questions arose about proportionality and suffering in confined spaces. These debates remained largely internal during the war, overshadowed by immediate operational needs. If a weapon reduced the need to crawl toward a firing port under machine gun fire, it was used. Even so, planners recognized that the Boom Devil was not a long-term solution. Its production was expensive. Its components required skilled labor. Its sensitivity made peacetime storage problematic, and its risks limited its appeal outside the extreme conditions of Pacific Island warfare. The ammunition solved a specific problem at a specific moment. Once that moment passed, its flaws became harder to justify as the war moved toward its conclusion. Product piles grew, usage became more selective. Discussions began about what would happen when the fighting stopped. The Boom Devil had proven that innovation could break even the most stubborn defenses. It had also proven that some solutions were too dangerous, too complex, or too controversial to survive beyond the crisis that created them. And that realization set the stage for what came next. When the war ended, The Boom Devil did not become a legend, it became a secret. In August 1945, Japan surrendered. Combat operations stopped almost overnight, but production orders did not simply fade away. They were canceled abruptly. Frankfurt Arsenal received instructions to halt manufacturing immediately, segregate all remaining inventory, and prepare it for classified Thompson rounds produced. Only a portion had ever reached the front lines. The rest were sealed away in reinforced containers, removed from circulation, and logged under security classifications that placed them beyond public reach. There was no press release, no post-war analysis, no mention in infantry manuals. The weapon that had reduced casualties and broken fortification disappeared without explanation. Security oaths were enforced strictly. Veterans could describe cave fighting. They could talk about Thompsons, flamethrowers, and bunkers, but the explosive ammunition, and the detail that chained everything, was off limits. Corporal James Donovan returned home in 1946 and went back to civilian life. He raised a family. To anyone who asked, Peleliu was just another brutal island battle. He did not tell his wife what was inside those wooden crates. He did not tell his children why certain bunkers fell faster than others. For decades, he said nothing. The secrecy was not arbitrary oxblade and uncomfortable space. It was effective. It was dangerous. And it raised questions the military did not want to answer publicly in the immediate aftermath of the war. How far could innovation go before it crossed a line? What happened when a weapon worked too well in confined spaces? By the 1970s, time began to erode those barriers. The Freedom of Information Act forced the gradual release of World War II ordnance records. Documents long buried in archives were reviewed, redacted, and partially declassified. References to the M1 frangible grenade cartridge surfaced quietly, without fanfare. Even then, the disclosures were incomplete. But enough information emerged to confirm what veterans had known all along. The Boom Devil had existed, and it had been used by that point. Another problem had emerged. The explosive rounds were aging. Composition C2, like all energetic materials, degraded over time. Some rounds showed crystallization, others became unstable. Storage conditions that were acceptable in wartime warehouses were no longer sufficient for decades-long containment. The Army faced a choice: maintain an increasingly dangerous stockpile indefinitely or destroy it. Destruction was chosen between the late 1970s and early 1980s, remaining Boom Devil ammunition. Each round was X-rayed to assess detonator condition. Unstable cartridges were handled individually. Controlled detonations were conducted one at a time. The operation took years and cost millions of dollars. By the time it was finished, although the explosive Thompson rounds were never reintroduced, the idea behind them endured. Modern infantry doctrine increasingly emphasized the need for organic fire, capable of defeating hardened positions without relying on engineers or heavy support. Thermobaric airburst munitions, thermobaric weapons, precision-guided rounds designed to exploit confined spaces. Each reflected lessons learned decades earlier in coral caves and concrete bunkers. Cost, complexity, and risk continued to limit explosive small arms ammunition. What made it viable in 1944? But desperation, urgency, and total war, but did not exist in the same form afterward. For historians, the story raised deeper questions. Why did such an effective weapon vanish so completely from public memory? Why was it absent from most popular accounts of the Pacific War? The answer lies not in failure but in discomfort. The Boom Devil challenged assumptions about how wars are fought and remembered. It was not a hero's weapon in the traditional sense. It did not win battles through bold charges or overwhelming fire. It worked quietly, efficiently, and decisively, turning the enemy's strongest defenses into liabilities. It saved lives, and it did so in ways that were difficult to celebrate openly. When Donovan finally spoke about the ammunition years later, he did not describe it with pride or horror. He described it as necessary, a tool that arrived at the moment it was needed and disappeared when it was no longer acceptable. That may be its true legacy, not as a miracle weapon, not as a forbidden experiment, but as proof that in war, innovation is often born from failure, shaped by desperation, and hidden once its consequences are fully understood. On Peleliu, concrete bunkers believed they were invincible for 48 minutes. They were proven wrong, and then for 31 years the reason why was erased.